didn't get that.
It says find the exact values of the composition without using a table or a calculator. And so here we're dealing with compositions. And these aren't bad. You're simply finding, it's a two-step problem instead of a one-step. Start inside parentheses with the inverse tangent of 0. So we're asking ourselves first, the tangent of what angle is 0? And what would that be? The slope of what angle is 0? Because think slope when you're thinking about tangent. Careful, slope of 90 is undefined, so 0. So you're dealing with the sine of, this is 0 degrees. So you're just asking yourself, what is the sine of 0 degrees? Which is also 0. Second one, the arc sine, and keep in mind that when we're dealing with arc sine, we're going from negative 90 degrees to positive 90 degrees. The arc sine of the cosine of 30 degrees, because pi over 6, that's 180 divided by 6, that's 30 degrees. Start inside. Raj, what's the cosine of 30 degrees? Good. So we're simply on this problem looking for the arc sine or the inverse sine of root 3 over 2. Okay. Since we're dealing with arc sine, again, we're dealing with an angle between negative 90 and positive 90. Since our sine is positive, that means we're going to be in the first quadrant, because again, this is fourth quadrant to first quadrant. So since our sine is positive, we're in the first quadrant, and the sine of what angle is root 3 over 2? 60 degrees. Or since we're dealing with radians, let's call it pi over 3. Next one, the tangent of the inverse secant of root 2. We don't know how to find inverse secant, so we're going to change that thing to cosine stuff. So we now have the tangent. The tangent of the, again, secant and cosine are reciprocals of each other. So the tangent of the inverse cosine of, you got to flip that argument. It'll be 1 over root 2 or root 2 over 2 once you rationalize. Inverse cosine of root 2 over 2. Again, keep in mind that when you're dealing with inverse cosine, you're going from 0 to 180. Since it's positive, we really don't have to worry about it. Any of the inverse sine, inverse cosine, or inverse tangent, if it's positive, you're in the first quadrant. Inverse cosine of root 2 over 2. What is the inverse cosine of root 2 over 2? Good. Cosine of 45 degrees is root 2 over 2. So we're simply looking for the tangent of 45 here, which is 1. Let's work a few more of those, because sometimes they flip-flop. Yeah, let's try this one. The inverse sine of the sine of 5 pi over 6. Because this, you would think, well, inverse sine and sine, aren't those inverses of each other? Right? So you would think, oh, my answer is 5 pi over 6, right? You would think. It's not. Because normally, if you take x plus 3, and then you subtract 3 from it, you end up back at x. But not the case here. The inverse sine of the sine of 5 pi over 6, what is the sine? Let's see, that's, again, think pi over 6 is 30. 5 of those would be how much? 150. So we're looking for first the sine of 150 degrees. Anybody? Would be 1/2. Because that would be a reference angle of 30 degrees. Sine of 30 degrees is 1/2. But do you see the issue here? So now we're finding the inverse sine of 1/2. When you're using the inverse sine, it's going to give you an answer between negative 9 and negative 90 and positive 90. 5 pi over 6 is not between negative 90 and positive 90. Inverse sine of 1/2 is going to be in the first quadrant. It's going to be positive. Since this is positive, sine is going to be positive. It's going to be between 0 and 90 in the first quadrant. Sine of what angle is 1/2? 30 degrees. Or, just in case, since that's in radians, 180 divided by 6 is 30, pi over 6. Find the inverse. Reminder to find inverses. Let's go back and work a simpler problem. Y equals x plus 3. We found inverses back a few chapters ago, and again, all you got to do to find inverses, an inverse is simply you're switching your inputs and your outputs. Okay, here your input was x, you put in a 1, you get 4. You put in a 2, you get 5. You put in a 3, you get 6. But the inverse would be x equals y plus 3, or if you solve that would be y equals x minus 3, which would actually carry in the opposite direction. Up here you put in a 1, you got 4. Down here you put in 4, you get 1. That's what inverses are. But again, to find inverses, you're simply switching your x and y. It's a little bit tougher here. Your original problem is y equals 3 times the sine of 2x plus 5. And it actually gives you where x is between negative pi over 4 and pi over 4. So your domain, it's giving you domain here. Your domain is from negative pi over 4 to positive pi over 4. And it says, and determine the domain of f inverse. Now, let's go ahead and do it first, because it's actually pretty easy. Think about what you're about to do. You're about to switch your x's and y's. Where x is, put a y. Where y is, put an x. Isn't the domain the set of all x's? And you're going to look for the domain of f inverse. After you finish this all, the domain of f inverse, well, think about it. Would that not be the range of this? The domain of this, well, let's go ahead and find range. Let's just do that. What is my range? And then we'll use that to kind of explain. Normally your range for sine is from where to where? Remember what sine looks like? -1 up to +1. That makes sense. But we've got some transformations here, and this is another reason we go over transformations. This range has been made 3 times taller, and it's been moved up 5 units. So let's take our -1 to +1. Let's make it 3 times taller and 3 times shorter, I guess you could think of. Where's it at now? Stretch it 3 times. Any ideas? Yeah, there we go. -3 to +3. And then we're going to take it and we're going to shift it up 5 units. So our -3 turns into 2. Our +3 turns into 8. So the range of this function is from 2 to 8. So now let's work it out, and we'll talk more about that in just a second. To find the inverse of this, y equals this stuff turns into x equals this stuff. So we now have x equals 3 times the sine of 2y plus 5. Solve it for y. Let's move our 5 over by doing -5. And to save some paper, let's go ahead and move the 3 over by, since it's multiplied, divide it. Reminds me a lot of logarithms. We did the exact same thing with logarithms when we found inverses. Except for when we dealt with logs. Remember this? At this point with a logarithm, we'd take our base of, in this case, it would be base of 10. 10 to this power equals the argument. But sine, cosine, tangent is a little bit different, right? To get rid of logs, we had to change forms and go exponential. But to get rid of sine, we simply do inverse sine. So we move our sine over. We now have the inverse sine of this junk equals 2y. To get rid of the 2, we're going to divide by 2, or I would actually rather you do this. Instead of division by 2, multiply by 1/2. It just looks better. So you now have 1/2 times the inverse sine of x minus 5 over 3 equals y. Or we can now call it f inverse. That's the inverse of f. But now we're looking for the domain of that. What all things, if our original domain was restricted from negative pi over 4 to pi over 4, then how are we going to find the domain of this? Again, guys, think about what we just did. We switched our x and y. We just switched our domain and range. So the domain of this, anybody want to take a stab at what the domain of this is going to be? Yeah, 2 to 8. The range of the original is now the domain of your new function because we switched our x's and y's.